These are the answers to the Chapter 9 test for organic chemistry. Number 1 starts with 17 different prediction of products questions at 2 points each for 34 points. Starting with the first one. We are reacting with HBr. This indicates hydrohalogenation, so that tells us that we're going to add Br to the more substituted carbon, which would be either of these really. However, we have a neighboring methyl group, so I think one possible answer would be Br attached to either of these carbons. So that's one possible answer. Another possible answer would be the other, again, vinylic carbon. But I think a third possible answer, and all of these would be accepted, would to have a hydride shift happen. So this hydrogen here can shift over to this carbon if there's a carbocation formed. Well, there is a carbocation formed, which would put our bromine along on the same carbon with that methyl group. So a third possible answer. So I think all three of these answers should be allowed, but my favorite answer would be this third one, showing that hydride shift. Next question, we have ozone. So this is ozonolysis. I think the easiest way to do that is to just think of the pi bond breaking, and we have a double bond to an oxygen on one end of our molecule, and then a double bond to an oxygen on the other end of our molecule. So you could draw it like this, but usually it's gonna unwind itself because this really isn't a favorable position for the molecule. So I'm gonna draw it more like this, starting with this end. So here's my double bonded oxygen, and then my first carbon, which would be here. Here's my methyl group, and then I'm just going to continue the chain. So here's my 1, 2, 3, 4, 5, 6 carbon ring that's been drawn into a chain. So here's my other double bonded oxygen, and that would be the end of the molecule. So here's our answer for the second one. Third reaction, again, similar to number 1, we have hydrohalogenation with HBr, so we're going to expect Br to be on the more substituted carbon, which would be this carbon. So we have a pentane ring, and we have our ethyl group here, and then our bromine attached to that carbon as well. Next, have H2O and H2SO4. So this is acid catalyzed hydration. So I'm going to expect an OH to go on our more substituted carbon, which will be this one. So I'm going to expect an OH here. And that's going to give me a product that looks like something like this. And that's our answer for the fourth one. And then the fifth one, I've noticed mercury here. And this is what is it? Mercuration, demercuration, which is the addition of hydroxide on the more substituted carbon. So hydroxide on the more substituted carbon here. So our product is going to look like this. Okay, that's our fifth answer. Okay. Answers 6 and 7. We have MCPBA. MCPBA is the starting reagent for, I believe it was anti-dihydroxylation, but they're only showing MCPBA, so that means that we're forming the epoxide. So we're forming just the intermediate here. So that's going to be our I'm going to have oxygen forming as a ring here, a partial ring. So there's our epoxide formation. So that's what they're looking for that final product. And then going the other way, we just have, again, hydrohalogenation. So again, that's Br added to the more substituted carbon, like that. Next one we have, this is acid catalyzed hydration, but here we have an alcohol as our, instead of OH, we have ethanol as our nucleophile. So we're going to add not just OH, but we're going to add to the more substituted carbon here, we're going to add O and then our ethyl group. So it's going to look something like this. And then here's our, instead of OH, we've got, again, our ethyl on our oxygen. The other way, we've got acid catalyzed hydration. So this would be our OH. So it's basically the same product we just drew, but instead of our ether we're forming our alcohol. So OH, but same rules. Add OH on the more substituted carbon. We've got another MCPBA, which is going to form our epoxide. So it's going to look something like this with our 5-carbon ring, our pentane ring. So we're going to have our methyls. Again, those didn't change, but now we're going to have our epoxide ring. And then over here we have HBr, so we have hydrohalogenation. Again, that's Br on the more substituted carbon, which would be this carbon right here, which is going to give us Br, like so. Okay, moving along. Okay, we got BH3. This is an anti-Markovnikov addition of OH. So this is going to give me my OH attaching to the less substituted carbon. So that's going to give me a product that looks, let's see, we got our methyl here. We're going to have our OH here. Now I did draw this one, if this were a wedge, this is going to be a syn addition of our H to the more substituted carbon and our OH to the less substituted. So I would have dash dash for OH and H. Or I could have had wedge wedge, but then this methyl would have been a dash. And then over here we have mercuration demercuration, which is going to be the addition of OH to the more substituted carbon, which is going to show us something like this. All right, we're almost done with number 1. I've got HCl, hydrohalogenation. Again, that's Cl attached to the more substituted carbon, which is going to be this one. So we've got a product that looks something like this. And then here we have hydrogenation. Hydrogenation is going to be the addition of hydrogen, the syn addition. So that's going to give us a product that looks like this. So we would have a hydrogen, let's say we would have a wedged hydrogen and another wedged hydrogen here and here. So this is a syn addition. So that would make our methyl here a dash. So a dashed methyl, wedge, wedge, or we could have gone wedged methyl, dash, dash, either one. And the last one for number 1, NBS. You know what? NBS didn't show up in any of my posters. I had to do a little research on this one, so I don't think this one was entirely fair. But what I identified is that it's kind of a bromination, but there's also, you have water. So what this ended up being was Markovnikov addition of OH. So you're going to add OH to the more substituted, but then we had a bromine added to the less substituted. So it was almost like a bromination, but with water adding as your OH to the more substituted. So this was then a product that looks something like this. So we've got our methyl. I drew our methyl on a wedge, got a dashed OH, and then a wedged bromine. I believe that's what we would have here for that. And then lastly, we have osmium tetraoxide, so that's going to be a syn addition of OH across the pi bond. So that's going to look something like this. So I'm going to make our methyl a wedge. So this methyl is a wedge, so that's going to be OH on a dash on each of these. So that's our syn addition of OH. And that's number 1. So I'm going to stop the video there. I'll make another video for number 2, and then another video for number 3, and so on.